Let us see about the characteristics of practical frequency selective filters and the characteristics of commonly used analog filters, Butterworth filters and Chebyshev filter. Now we can see the characteristics of practical frequency selective filters. First one is the low pass filter, second one high pass filter, band pass filter and band reject filter. Low pass filter, it only pass the low frequency. High pass filter, it only pass the high frequency. Band pass filter, it pass only some band of frequency to pass through them, and the band reject filter, it rejects some band of frequency to pass through them. While we are finding the digital filter versus the analog filter, in the case of analog filter possesses analog input and generates analog output. A digital filter possesses and generates digital data. They are, in the case of analog filter, they are constructed from active and passive electronic components, and the digital filters, it consists of elements like adders, multipliers and delay unit. Analog filters is described by the differential equation. Digital filters is represented by the difference equation. And the filter, in the case of analog filter, the frequency response of the analog filter can be modified by changing the component. But in the case of digital filter, the frequency response can be changed by changing the filter coefficients. And some of the advantages of digital filters are, unlike the analog filter, the digital filter performance is not influenced by component aging, temperature and power supply variation. A digital filter is highly immune to noise and possesses considerable parameter stability, and the digital filters offered a wide variety of shapes for the amplitude and phase response. There are no problems for input and output impedance matching with the digital filters. Digital filter can be operated over a wide range of frequency, and the coefficient of digital filters can be programmed and altered anytime to obtain the desired characteristics. Multiple filtering is possible only in digital filters. While we are going for this higher digital filter design, the analog filter design, it is divided into Butterworth filter, Chebyshev filter and elliptic filter. The Chebyshev filter is again divided into type 1 and type 2. Now analog Butterworth filter design. First, we want to find the order of the capital N by using this formula, where epsilon and lambda is find out by using the formula that is given. Second step, now we are rounding the value of n to its next higher digit integer value. Now we want to find the normalized transfer function h of s for omega c equal to 1 for the value of n. Therefore, h of s equal to numerator divided by denominator. Now the Butterworth filter numerator polynomial is always 1. After finding that value, we want to calculate the cutoff frequency of omega c by using the formula that is shown. And next, fifth step, find the transfer function h of s for the above values of h of omega c by substituting s equal to s by omega c in h of s. For high pass filter, h of s equal to h of s is equal to s is replaced by omega c by s, and in the case of low pass filter, s is replaced by s by omega c. Now at last we want to find the value of h of s. And then next one is the analog Chebyshev filter. This is Chebyshev 1 transfer function, and next one is this Chebyshev 2 transfer function. Now we want to find, same as in the Butterworth filter, here also the first step is used to find the order of the filter n. Now we are rounding the value to the next higher digital integer value. And third step, by using the following formula, find the values of a and b which are minor and major axes of the ellipsis respectively. That is a, b we are finding, and while we are finding a and b, we want to find the value of mu and epsilon. Step 4, we want to calculate the poles of Chebyshev filter which lie on the elliptic by using the formula sk equal to this value and y5k equal to this the formula shown. After finding the value, find the denominator polynomial of the transfer function using the above poles. Next, sixth step, we want to find the numerator of the transfer function. It depends upon the value of n. First case, if n is odd, substitute s equal to 0 in the denominator polynomial and find the value. The value is equal to the numerator of transfer function. And second, if n is even, substitute s equal to 0 in the denominator polynomial and divide the result by the root of 1 plus epsilon square. The value is equal to the numerator value. Thank you.